And welcome back, students, to our last lesson on optimization. Today we're going to discuss when to optimize. So optimization can reduce the readability and add code that is used only to improve performance. Because remember, that's the whole objective of optimization is to improve performance. However, this may complicate programs or systems, therefore making them harder to maintain and debug, as we kind of mentioned with the trade-offs and bottlenecks. As a result, optimization or performance tuning is often performed at the end of the development stage. Now, as your program's all written, you have most of your bugs are pretty much out, now you're just looking to fine-tune it to try and increase performance. Approaching the when aspect of optimization, typically what you'll see is you design first, then you code from the design, then you profile or benchmark the resultant code to see which parts of it should be optimized. A simple and elegant design is often easier to optimize at this stage, and profiling may reveal unexpected performance problems that would not have been addressed by premature optimization. So that's another reason why you kind of want to just wait until the end. In practice, it is often necessary to keep performance goals in mind when first designing software, but the programmer balances the goals of design and optimization. So while performance, remember we said, is part of the key thing, like some of the things like your data structures, you should keep those in mind. But you also want to keep in mind other things that you might be using. Modern compilers and operating systems also are so efficient that the intended performance increases often fail to materialize because they're just so much more efficient today with PCs and any other kind of machine device that uses this kind of stuff comparatively to like when computers were first coming around, like the amount of performance power that we have. Like just look at a cell phone and how much computational power that has. Automating optimization. All right. Optimization can be automated by compilers or can be performed by programmers. However, the gains are usually limited for local optimization and they're much larger for global optimizations, where you're looking to optimize a whole program. Usually the most powerful optimization is to find a superior algorithm, so finding a better thing to reduce your big O, for example. If you are right now, let's say, running at n log n, but you can get it down to just log n, that's great. Optimizing a whole system is usually undertaken by programmers because it's too complex for automated optimizers. In this situation, programmers or system administrators explicitly change the code so that the overall system performs better. Although it can produce better efficiency, it is far more expensive than automated optimization. So optimizers, they can go in, it's a lot more cost efficient because you don't have to spend the man hours on it. It tends to produce not as good results. And while we're on automatic, let's talk about manual. Manual optimization sometimes has the side effect, though, of undermining readability. Thus, when you do those manual code optimizations, they should be carefully documented, preferably using like inline comments, and their effect on future development evaluated. So if you go and make a change to your code, you probably should look later on, it's like as you're making more tweaks to your program, how that's going to affect everything. Comparatively, automated optimizations are almost exclusively limited to compiler optimization. All right, and we need to talk about optimization time. Sometimes the time taken to undertake optimization, there in itself, may be an issue. So, in order to fix this, it takes time to fix all the stuff. And part of that has to do with optimizing existing code usually does not add any new features. And in the worst case scenario, it actually may introduce new bugs into your system into previously working code, as with any change that you make to your code. Because manually optimized code might sometimes have less quote-unquote readability than unoptimized code, optimization may impact the maintainability of it as well. Remember, it said maintainability is ability to go in and do bug fixes, stuff like that. But if you remember, we said using inline comments are great to help document stuff. If you don't have the documentation, you may come back 6 months from now like, what does this block of code do? I don't remember. Optimization comes at a price, and it is important to be sure that the investment is worthwhile. That's one of the big things with any business. Before they go invest time and money on something, they want to make sure that that investment is going to be worth their money. And that concludes our notes, folks. Until next time.